How's it going, guys? We're going to look at 1353 in this problem. And before I do it, this problem is one of those problems where you have a car going around a banked track. Okay, what is a banked track? It just means this car is driving around on a racetrack. Okay, this is the top view, and this is the front-on view or the back view. But as it's going around the racetrack, it drives at an angle to the, I guess, to the flat surface, and we have to again ask the question why. Okay. Recall in the previous video I showed you this, the previous video on example 13.3. Okay, you can go watch that one. Essentially, what I was trying to convey to you guys is that if a car is going around a bend, around a curve, right? You can see that that's a curved track. Oh, yeah, it's a curved road. So the car's trying to go around the bend. What is the only force if this is flat? If the road is flat, right? And there's the car. There are your wheels on the side. Okay, just imagine. Just use your imagination. And it's going around a bend like this. What are the only forces that are causing the car to travel in the circular path? It will be friction, right? Friction at the wheels. So as you're driving here, then the driver turns the wheels to follow the direction of the road. But actually what's happening is that there is this friction force on the wheels that's constantly pushing the car accelerating the car towards the center as it goes around the bend. Okay? Now, if you're going at high speeds, actually it doesn't really matter at what speed. The basic idea is that so you've got there your friction forces, right? There's the tires, okay? If we want to go at much higher speeds, and we want to not have to rely so much on the friction force, because the friction force has a limit, right? What is the limit of the friction force? Fs equals mu Sn. Recall that if you're looking at your friction force, it looks something like this, right? And that maximum value is called your limiting friction, limiting static friction, okay? Or impending motion, okay? That's at impending motion. So if you increase the force just slightly, then it's going to go into its kinetic friction range, okay? So this is your limiting static friction. The point is that that's the maximum that those tires can handle, is this friction force. But if you want to go at higher speeds, it's very wise to change that angle so that you are not only relying on friction, right? F friction there. You are also relying on the normal force, and both of these will then have components that will push you towards the center of the curve. Okay, I hope that's making sense here. Okay, so that's essentially what we had with this example 13.3. If it'll just focus, is that this problem was asking us at what angle should we bank this road at so that we do not have to rely on friction. Okay, so that was that kind of problem. This problem says the sports car having a mass of 1,700 kilograms travels horizontally along a 20-degree banked track. So now this is fixed, right? We're not trying to solve for this. We're not trying to calculate the angle. It's given to us. And the radius of curvature is rho equals 100. So at a certain point, the radius of curvature, that's your radius of curvature, is 100. Okay? And it says if the coefficient of static friction between the tires and the road is mu s, okay, Determine the maximum constant speed at which the car can travel without sliding up the slope. Okay, so what's happening here is that we are given this angle, theta, okay? And we know now that we're going to have, we'll do a proper drawing now. We're going to have a normal force here, and we're going to have friction. That is, both of these components will contribute towards the car moving in a curve. Okay, but the question is, determine the maximum constant speed. Okay, so do we see that at a specific angle, right? At a specific angle, we can go at a certain speed, and we can keep increasing the. Let's rather say this. At a specific angle, we can go at a certain speed, so that the friction force here that is being applied at the wheels is sufficient to stop the car from sliding up the track. Here we go, like this one here. So this car here is going around the track, okay, and there's friction acting at the wheels here, right? Friction. If you keep going, and you can keep going up until a maximum velocity where F friction then reaches your mu Sn, which is your limiting static friction, okay? It reaches the maximum friction. And if you increase the velocity a little bit more, you're going to go larger than this value, and you're going to begin to slide, okay? So I hope that makes sense. So let us have a look here. We'll try to quickly do this. Here's the car. Remember, we choose the normal direction and the binormal direction. And then what are the forces acting on it? We have friction, F friction, and we've got mg, and we've got our normal force. So in this case, we have these three forces acting on the car, okay? And we know that that's 20 degrees, okay? We know that that is 20 degrees. So let me just zoom out a bit quickly. All right. So we've got some of the forces in the normal that are positive is equal to mv squared over rho. All right. What are the forces in the normal direction? We're going to have n sine 20. All right. Normal sine 20. It's that component there. Plus F friction. It's going there like that. Cos, if I'm not mistaken, 20. And it looks like those are the only two. And we're going to have, that's m over rho, which is 100. And we have v squared. Okay? V squared. So there we have that equation. Then we take sum of the forces in the binormal direction equals, what does it equal? 0, right? What are the forces? It will be normal cos 20, take up as positive, minus F friction sine 20 minus mg gives us 0, equals 0. All right. Now, so now that we've set this up, what is the next thing that we need to understand? The concept is that the maximum frictional force, the maximum is mu Sn. If the frictional force goes above this, then we will begin to slide, right? We'll begin to slide. If it's greater than that. Okay. So now all we need to do is plug in mu Sn into our friction variables here. Okay. That's all you do, guys. Take mu Sn, plug it in there, and we solve. okay, and you solve for your unknowns, you will get the normal force is 19.14 kilonewton, and you'll get the maximum velocity equal to 24.4 meters per second. If we go at a velocity higher than this, we will begin to, this frictional force will no longer be the static frictional force, but will begin to slide out. Okay, hope this helps. Cheers.